Welcome to this explainer. It's wild to think about, but today we're diving into exactly how a company best known for powering video games quietly engineered the biggest technological revolution we've seen since the internet. Seriously, it's a total masterclass in patience, vision, and impeccable timing. But to really get a handle on where we are right now, we gotta rewind just a little bit. Picture this. It's 2022 and NVIDIA is facing a brutal reality. They literally lost nearly two-thirds of their market value in under a single year. Critics were swarming, people were openly questioning the company's future, and a lot of investors just assumed, hey, they're just casualties of a fading crypto boom. Honestly, people were wondering if the company's absolute best days were completely behind them. But then, jump ahead just 2 short years. The global market was completely stunned, which begs the million-dollar, or really trillion-dollar question: who became one of the most valuable businesses in human history? We are talking about a company that suddenly skyrocketed past tech titans, leaving Apple, Microsoft, and Google in the dust when it comes to market dominance. The answer, of course, is NVIDIA. Now, what's so fascinating about this entire story is that this was absolutely not an overnight success, not even close. This hardware giant spent decades quietly laying the groundwork for a future that, frankly, nobody else saw coming. Fast forward to today, governments are treating their chips like vital strategic assets, and entire AI startups literally live or die based on whether they can get their hands on this hardware. So how exactly did they get there? Section 1. The Parallel Processing Pivot. If we trace their journey back to 1993, you'll see NVIDIA's path was anything but a straight line to the top. They were founded by 3 super ambitious engineers: Jensen Huang, Chris Malachowski, and Curtis Preem. Their original vision was pretty straightforward: create specialized processors to drastically improve computer graphics. But looking at the late 90s, wow, it was rough. They survived near bankruptcy, coming within just months of totally running out of cash after an early commercial product basically flopped. Yet somehow, they pushed through that turbulence and ultimately planted the seeds of an absolute empire in 2006 with their CUDA software platform. So how on earth did they bounce back from the brink back then? Well, you can largely thank gamers for that. As the gaming industry blew up, developers wanted richer 3D environments, increasingly realistic visual effects, and buttery smooth animations. All of that required a processor capable of performing millions of mathematical calculations at blazing speed. And right here is the absolutely crucial point. This relentless drive to render awesome video game graphics was actually foreshadowing the exact computational needs of modern artificial intelligence. The big takeaway here? Consumer entertainment was secretly funding the R&D for the AI revolution. And this right here perfectly illustrates the core architectural difference that completely changed modern computing. Think about traditional CPUs. They're built for sequential processing. They are amazing at handling general-purpose tasks, but they do it one at a time, kind of like a single chef working in a kitchen. NVIDIA's GPUs, on the other hand, are engineered for parallel processing. Instead of solving one problem sequentially, they can execute thousands of operations all at the exact same time. Jensen Huang looked at this and had a light bulb moment. He realized if GPUs can do these massive calculations so incredibly fast for images, they could probably solve massive problems way beyond just video games. Section 2. Working alongside Intel. Okay, so at the time, Intel basically owned computing. Everyone, from developers to investors, just assumed the CPU would be the center of the computer universe forever. So NVIDIA made a radically different, honestly brilliant bet. Instead of going head-to-head with Intel in this super expensive war to replace the CPU, they decided to build specialized hardware that worked seamlessly alongside it. They weren't trying to conquer the CPU market. They just wanted to accelerate specific visual workloads right next door. That one single decision was a total game changer. It allowed them to grow steadily without drawing a giant target on their backs. Section 3. The CUDA ecosystem moat. Meanwhile, inside universities and research labs all over the world, scientists were facing a massive bottleneck. They desperately needed enormous processing power for complex stuff like weather simulations, molecular modeling, and crazy physics experiments. These researchers figured out pretty quickly that NVIDIA's graphics chips were insanely good at the exact types of massive mathematical matrix computations they needed, but there was a major catch. The hardware was just way too hard to program. Most regular software developers simply didn't have the highly specialized knowledge to actually harness that GPU power for anything other than, well, rendering graphics. So this put NVIDIA at a massive crossroads. They could just keep selling hardware, right? Let the developers figure out the software headaches themselves. Or they could take a huge leap of faith. Jensen Huang shows the risky path.
His mandate to the company was incredibly clear: make GPUs dramatically easier to program, even if that investment produced little immediate financial return. And that bold move gave birth to CUDA in 2006. Now, the funny thing is, Wall Street barely even blinked at the time. They only cared about graphics cards and immediate quarterly profits, not some obscure niche software development platform.
But just look at how it played out. This brilliant lock-in effect took hold in 3 distinct phases. First, universities actually started teaching CUDA to their computer science students. Then, step 2, those same researchers graduated and started building complex computing libraries around it. Finally, step 3, entire companies began optimizing their specialized applications specifically for this ecosystem. Once researchers learned CUDA, trying to switch to another hardware platform became a total nightmare. A quiet, inescapable, deeply entrenched ecosystem was formed, and competitors literally couldn't replicate it, even if they had comparable hardware.
Section 4. Powering the AI Revolution.
You know, for decades, artificial intelligence went through these wild cycles of massive hype, followed by total, crushing disappointment. But slowly, right beneath the surface, the fundamental conditions aggressively changed. Machine learning models got significantly larger. Datasets grew exponentially, and the underlying algorithms rapidly improved. AI wasn't just going to remain this cute, niche academic field anymore. It was finally preparing to scale.
But suddenly, those AI researchers hit a wall. They discovered that training these massive, increasingly sophisticated neural networks required, you guessed it, enormous amounts of parallel computation. Sound familiar? It was the exact same kind of repetitive parallel matrix processing that NVIDIA's gaming chips had been flawlessly executing for decades to render your video games. What started out as hardware just meant to draw pixels on a screen had officially become the underlying engine powering artificial intelligence itself.
NVIDIA spent over 20 years patiently building the engine for a future that nobody else even saw coming. They perfectly positioned themselves long before the rest of the world realized the AI wave was about to break. Which honestly leaves us with a pretty fascinating question to think about. If NVIDIA saw the AI revolution decades before the rest of the world did and patiently built the tools to control it, what invisible, highly complex ecosystem is being built right under our noses today? What massive technological moat is quietly being constructed right now that will completely define the next 20 years of our lives?